So, what is an example of a chemical change? So, here we got a couple of examples: butter melting and egg cooking, paper tearing, or water evaporating. And the right answer is B, an egg cooking. And this is a chemical change because you are chemically changing the egg, you are altering it permanently. You're not just changing the form of it, you're actually making it into something different, like paper tearing, water evaporating, butter melting. Those are all still the same substance. But actually cooking the egg, you're actually changing it on a molecular level. Now, 43, which chemical equation best represents the law of conservation of mass? Again, when we talk about the law of conservation of mass, we talk about the fact that matter is not created or destroyed. It can just be transferred from one form to another. And so for here, you would want to list out what you have for each one. So just like when you're doing your normal balancing of chemical equations, you want to list out what you have on the product and the reactant side. And when you do that, you'll see that C is the best answer there for you. And then for 44, which is most likely a major concern associated with burning fossil fuels? So, burning fossil fuels can cause a lot of things, and most specifically, can produce smog, which can cause respiratory illnesses. Now, of course, it can cause lots of pollution, but one of the major things is respiratory illnesses that it can cause. Now, it can pollute oceans, but that is kind of a byproduct. The more pressing concern is the respiratory illnesses. So, which action shows concern for the environment with regards to the resources of the ocean? So, we're looking for something that shows that you're caring about the environment, specifically looking at the ocean. And so, setting limits on fish harvesting in the ocean is definitely a way to look at how you are using the resources in the ocean, and making sure that you are mindful of that. So, developing technologies which will allow for an increase in fish harvesting, that definitely is the opposite. Allowing factories to release untreated wastewater, that's definitely not. And filling in oceanfront wastelands in order to extend beachfront properties, all those things are the exact opposite. So, none of those are it, except for D. Which effect does the water cycle have on the total amount of water on Earth? And again, this is consistent, it remains the same. We've talked about this numerous times. Which characteristic of water quality provides the most information regarding the health of a water system? And so, again, the animals and species and things like that that live there, that's going to give you the best indication of the water quality itself. So, what kind of wildlife and things like that that you find there? All right, so we've been over some questions like this already, but to recap, where's most of Earth's freshwater located? And that's in the ice caps, right? They are frozen. We do not have immediate access to them. Which is the most accurate way of determining the age of a fossil? Again, this is radioactive dating. This is where you look at the uranium level, right? And you're seeing the half life of uranium and the amount that is in any given substance to figure out exactly mathematically how old something is, and which allows scientists to investigate what Earth's climate was like over the past 740,000 years. And this would be ice cores. Again, just like the rings of a tree, they tell a history. So they're going to be able to tell you what Earth was like, what was happening in the atmosphere on Earth's surface, and things like that at various points in time. So, which best describes uniformitarianism? So, again, this is basically saying that all the processes that have been happening on Earth since the very beginning, that shaped the Earth, are still happening now. Now, these are things like, the water cycle, nitrogen cycle, um, you know, magma cycles, things like that. That all of those things that have been happening since the beginning of time are still currently happening on Earth. Now, that's not to say that humans have not impacted it, whether for the good or the bad, but those big processes are still happening now, and they will continue to happen. So that's what that means. So C is the answer there. And then 52, many infectious diseases have been nearly eliminated worldwide. Why should global studies of infectious diseases continue? And that's because these diseases can mutate, right? They can change over time. So we want to be aware of those and make sure we know how to treat them. And so C would be the best answer there. And 53, scientists have been able, or not been, or sorry, excuse me, scientists have been able to cause some bacteria to produce insulin. In which area of science would these scientists most likely work? And that would be biotechnology. And again, this has to do with advancing medicine or advancing farming or making life in general better. So, 54, if a company genetically modifies corn to produce an odor that repels insects, which best describes how the corn was modified? And so this would be by techniques used to or used in biotechnology. And again, biotechnology, we're talking about advancing agriculture or medicine when we talk about biotechnology. And so again, that is what it does. So yes. 55, which best represents the flow of energy within an aquatic ecosystem. And so remember, we always want to start with an energy source being the sun, which is the primary energy source for pretty much all ecosystems. And then we want to start with a producer there. And if we're talking about aquatic ecosystems, the producers are typically algae. So we would need sunlight and we would need algae. So that automatically eliminates everything except D. So we need sunlight, algae, insects, fish, and then turtles. So D is the only one possible. And 56, if a bat, an alligator, and a bird evolved from a common ancestor, what most likely can be concluded? And this would be A. They have similar anatomical structures. And again, we talked about those previously. That is one of the biggest indicators. If you see that they have structures that maybe look a little different now, but they had a either common purpose or you looked at them through x-rays and they have commonly shaped bones and things like that, you can see that they might have had a common ancestor there. 57. Recent changes in species can be found in the upper layer of rocks, which this provides a link between which two scientific ideas. And so, if we're talking about something happening in rock or in layers of rock, that definitely lends itself to the law of superposition. And so, then that kind of gives us C or D. And then we've got here the periodic nature of the elements is not a theory or law, but the theory of evolution definitely is. So C would be our best one there. Theory of evolution. If we're seeing that the species is changing, that definitely falls into the category of the theory of evolution. So the theory of evolution and the law of superposition would definitely work for the answer there. 58. Which of these would most likely happen to a species that is not able to adapt to a changing environment? Well, if they're not able to adapt, then unfortunately they would not survive. So they would become extinct, which would be A. 59. A runner is preparing to run a long race. Which would provide the highest level of energy for the runner? And that would be carbohydrates. Carbohydrates for energy. Now, minerals and vitamins, they're necessary, but they're not for energy. And proteins, although your body does need them, they are not a good energy source. They are a building block for your body, but not a really good energy source. Why are digestion and respiration important to the body? They provide the energy needed for body functions. Now, of course, we know that digestion is breaking down the nutrition, and that is enabling us to get energy from the food that we eat. And respiration, that has to do with us being able to process that food and go through the process of cellular respiration and use oxygen to get the energy out of the food and our cells to be able to break it down. So both of those things have to work together in order for us to get and use the energy that our body needs.